Hello, geometry students, and welcome back to another video lesson as we continue exploring Pythagorean theorem, special right triangles. And today we learn another skill called rationalizing the denominator, expanding a little bit on what we did yesterday. And so yesterday we were working with this kind of a triangle where we had this 45, 45, 90. And they gave us the hypotenuse, which was 12, right? That's that hypotenuse. Now, in general terms, in a 45, 45, 90, 45, 45, 90. These two sides are n, and this side is n times the square root of 2. And because the 12 is the hypotenuse and it's in that spot, we said that 12 was going to equal n times the square root of 2. And then to get n by itself, we wanted to divide by the square root of 2. Or that 12 over the square root of 2 was equal to n. Right, that's where we left off yesterday, that these two sides were going to be 12 over the square root of 2. 12 over the square root of 2. And technically speaking, that is correct. That's right. The problem that we have, though, is when we look at this from a math context, it's not proper for us to leave square roots, these radical signs, square roots, in the denominator. We typically want to undo that process somehow, and that process is called rationalizing the denominator. It's a process of eliminating any radical or square root from the denominator. And what do? We take the problem and we multiply the top and the bottom by the square root of whatever on the bottom, right? 12 squares of 2 times square root of 2 over the square root of 2. The reason we can do this is that the square root of 2 over the square root of 2 is really just a different way of writing the number 1. Something but divided by itself is 1. And so we're not changing the problem, we're just changing the way that it looks. When we do this, okay, we get 12 times the square root of 2 on top, right? That's what we were talking about earlier in terms of simplifying. I can't combine them if one's on the outside and one's underneath. But on the bottom, when I do square root of 2 times square root of 2, that really turns into square root of 4. I can multiply them because they're both underneath. What is, right? We can't simplify the top anymore at this point. 12 times the square root of 2. However, what is the square root of 4 on the bottom? Well, that turns into a 2. And now I have this fraction, 12 over 2, that I can simplify and say that it's 6 times the square root of 2. I don't have a radical sign in the denominator. There's no square root down there. So this and this are the exact same expression. This one is just more mathematically correct. And so if we wanted to, we could replace those 12 square roots of 2 with 6 square roots of 2 and 6 square roots of 2. All right, so this one over here is more mathematically correct, we say, because we've gone through this process of rationalizing the denominator. All right, so anytime we have a square root on the bottom, we want to multiply by that square root. All right, let me just show you again a different example. What happens if I have 5 over, say, the square root of 3? Right, we don't like that, so we're going to multiply the problem by that number, that square root of 3 over the square root of 3, which turns into 5 square roots of 3 on top, over the square root of 9 on the bottom, because I'm multiplying those two. But really, the square root of 9 on the bottom is 3. Can I simplify 5 and 3 at all? We can't, so we would leave it as 5 square roots of 3 over 3. All right, so let's just take another look at a different example with a 30, 60, 90 degree triangle. All right, here's what it is on the left. This is the triangle we're trying to solve on the left. We're trying to find x, we're trying to find y. The one on the right is the generalized one with formulas. So this 9 right here, this 9 is really equal to what? It's in the n times the square root of 3 spot, right? It's opposite the 60 degrees, opposite the 60. So we're going to set it equal to n times the square root of 3. If I want n by itself, we divide by the square root of 3. Divide by the square root of 3. And we say that n equals 9 over the square root of 3. However, we don't like that answer because there's a square root. There's that radical in the bottom. So we are going to multiply by the square root of 3 over the square root of 3. Rationalize it. On the top, we get 9 square roots of 3. 9 times that square root of 3, all over the square root of 9. But we know that the square root of 9 on the bottom is 3. And then we check, can I simplify those two numbers since they're both outside? 9 over 3 is really 3, or 3 square roots of 3. That is what our n equals. That's our n. All right, so there's the n. It's opposite the 30. So which variable is that in our triangle? Is that x or is it y? Well, it certainly is x. 3 square roots of 3. Right? That's like our n. This was like our n square roots of 3. And therefore, how do we find y? Well, it's 2 of our n's. So I've got to take 2 times the n, or 2 times, what's the n? That's this one over here, 3 square roots of 3. 2 times 3 is 6. Can't do anything with that square root of 3 because that is also by itself. So we could say x equals 3 square roots of 3 and y equals 6 square roots of 3 after we've gone through the rationalizing part. Okay, 3 square roots of 3, then we used that. Now here's the last one. Find the area of this trapezoid below. Find the area. Well, the formula for area of a trapezoid is 1/2 times the height times base 1 plus base 2. If you look at that formula, we've certainly got a base 1 and a base 2. Do we have a height? Right now, we don't. Remember, a height has to be connected to the bases with the right angle. And so we typically drop that perpendicular straight down, and a perpendicular means it's a 90-degree angle. So if you focus on this triangle over here, this is going to be our height. Notice, what kind of special triangle is this? Well, that's a 30, 60, 90. Right, there's my right angle down here. This is our 60. They're telling me this one is 8. So if we think back to all 30, 60, 90s, and I'm going to try and draw it the same way this one is. The 30 is up here. The 60 is over here. Opposite the 30 is the n side. Opposite the right angle is twice n. And opposite the 60 is n times the square root of 3. So if we look at this picture, the 8 represents the 2n. That's 2n. Or in this case, n equals 4. So I've got an n value of 4, which means, since 30's up here, this side is my n value, which is 4, and this side is n times the square root of 3, or 4 times the square root of 3. So what is the height of this trapezoid, or what's the height of this triangle? 4 square roots of 3. And now we can use that information, 4 square roots of 3 as the height, and our two bases to find the area. 1/2 times the height, which is 4 square roots of 3, times 15 plus 23. And if we follow the order of operations, that's going to be 1/2 times 4 square roots of 3 times 38. Because it's all being multiplied, I can take half of 38 and say that that's going to be 19 times 4 square roots of 3. And because 19 and 4 are both on the outside, we can multiply those together to get 76 square roots of 3 for the area of that trapezoid. So a lot happening all within one individual problem. First of all, knowing what the 30, 60, 90 triangles look like and how to get their sides, using that as a height and plugging it in for a trapezoid. If you have any questions at all, folks, especially about rationalizing this denominator, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.